Hi everyone and welcome to Topic 8, Lesson 1. We are starting to talk about linear relationships and how we can represent linear relationships, what they are, how we can use them on coordinate planes and within equations. So we have a lot to cover in this topic. I would say arguably this is the most important chapter inside of 8th grade. So it's important to take your time in this series of videos, making sure you understand everything, because you do use this for the rest of your math career as well as most careers. Use some sort of version of the skills that we're learning in this chapter. So let's begin in your launch today and go ahead and pull up your student companion book and attempt this launch on your own, just using the information that you already have. All right, so we are being asked if we can determine which graph would represent each of the three situations over here on the right, the green, purple, and orange situations. And it's basically asking us which line, which blue line that's graphed, is going to align with this story. So the green one is the length of the line you draw with your pencil over time. So the length of the line you draw, so picture yourself drawing a line and continuing to draw that line without stopping. Is that line going to be getting shorter or smaller? Or shorter or longer? Hopefully you said it's going to be getting longer. So when you just start your drawing, it's going to be short. And then as you keep going, it's going to get longer. So this axis right here would represent time, and this would represent the length of your line. So this would be the correct one for, let me drag it in here, this first one. Okay, then the next one is the length of your pencil lead as you use it. So now we're starting a drawing, and as we use the lead, it's going to get dull. The pencil is going to run out of lead. So that would be a decrease. And then the length of your pencil lead if you're not using your pencil, well, that is just going to stay the same. If you're not using your pencil, the lead is not going to be changing. So that's kind of how we need to think about these different relationships here. So let's go ahead and take a look at part 1 of this lesson. So we are learning the definition for what a linear function is. And if you take a look at the word linear, you'll actually see the word line inside of it. And that can help you remember that a linear function is a graph that is a straight line. So a linear function. So which one of these would be a linear function? Well, right now, with the definition I've given you, you're going to say options 1 and options 3. Option 1 and 3 are both straight lines. And you're correct. These are both straight lines and they are linear. However, a function, there's one more rule about functions. Functions cannot be straight up and down. And they don't mention that, but they do tell you here that it's not a function here. So I did want to tell you, a linear function is a function whose graph is a straight line and is not vertical up and down. It can be horizontal. It can go left to right. It just cannot be vertical. So you might want to add that to your notes. A linear function is a graph that is a straight line and is not vertical, meaning going up and down. Okay, all linear functions, every linear function, actually every graph that you see here, can be represented by an equation. And we call those equations rules because it's a pattern and a rule that this line is following. So this line is following a certain rule, this line is following a certain rule, this line is following a certain rule. And a lot of times we refer to them as equations, but they're introducing it first to you as a rule. So a linear function rule is an equation that describes a linear function. Don't worry if you don't remember that there's a rule, just remember that every graphed line can be represented by an equation. So let's go ahead and dive into trying to figure out which rule describes each linear function. So I want to take a moment and introduce you to a tool called Desmos. I may have already showed this class but I don't remember. So Desmos.com is a wonderful website for graphing, and it's completely free to use. You don't need a login or an account or anything. And so if you just click Start Graphing, it works like a graphing calculator. And I want to kind of introduce you to what happens when you're working with different types of graphs. So let's start with this y equals 2x option. Actually, no, we're going to start with y equals x. If you notice, all of these equations have y equals and then some sort of x or x with another number over here, or this one's just a plain number. And that's because whenever we're working on a coordinate plane, we have an x and a y. So this is saying that every time the x is doing something, you can get a y also. So in this case, the 2 is being multiplied by x, and that's going to give you the y. In this case, a 2 is being added to x, and that's going to give you the value of y. Let me show you what I mean, and I'm going to start with this y equals x plus 2. And I'm going to plug this into Desmos so you can see it. Y equals x plus 2. Okay, let's take a look at what happens here. Previously, you've looked at using tables in order to graph a line or to plot points on a graph. And the way you did that was you made an XY table. So let me draw one here. We've got a lot of different tabs going on today. So you drew an XY table. And you said, well, if x is 3, what is y? If x is 0, what is y? If x is -1, what is y? Well, we can figure it out by saying, oops, back here, if we're using y equals x plus 2, that's our rule. We can write a little bit straighter here. Y equals x plus 2. So I would then just take this 3 and plug it in for x to see what I got. And I'd have 3 plus 2 equals y. And 3 plus 2 is 5, so y equals 5. So when x was 3, y was 5. What about if x was 0? If I take the 0 and plug that in for x, I'd get y equals 0 plus 2. 0 plus 2 is 2, so y would be 2. If I did -1 in for x, it would be -1 plus 2, which would be +1. So this is how I can generate a table of values to graph my equation. But what Desmos does is it says, I'm going to give you every possible value that could be on your chart. So if you take a look here, I'm going to drag my cursor along the line. All of these decimals and numbers that you see are all possible values that would be true if we plug them into our equation. That's why we get a line when we have an equation, because we could plug technically any number in for x and we'd be able to get a y value. I could plug 3.3 in and get a value. I could plug 5 in and I could get a value. I could plug 5.54 in and get a value. And if I zoom in even further, let me do this here, I can get even smaller decimals. So here's 1.065 or -0.937. So there's infinite amounts of numbers here. And because I can't plot, realistically, I can't plot every single point that could be a possibility for this equation to be true, that's why we draw a line. So we draw this line to represent that, hey, any number that goes along this line that we can get an xy coordinate for is going to be a true solution for this equation, or for our equation. All right, and let's just do a cross check here and look at some of these. So each of these lines here goes through the origin, so that's the center, the 0, 0 of my axes. And this one right here does not. It goes through the point 0, 2. You can kind of see under this gray dot. So I know that this line is not one of my options over here. So if I can't get rid of it. That's okay. So now let me see if I plug in y equals -x over here. And I'm going to leave this. So the red line is this first one. Y equals -x. This blue line is my next one. So this blue line represents y equals -x. And it does go through 0, 0. So it's possible that it will be one of our lines. Notice the type of line this blue line is. This line is going down if you read it from left to right. It's going down, and because it's going down, we call it a negative line. And if you're looking at the equation here, this negative sign right in front of the x is also a clue that it's going to be a downward sloped line. So if we go back to our Pearson tab here, and I look for ones that are going down, the only possibility is this one, and none of these other x's have a negative sign with it. So I'm going to go ahead and say this one is for sure the negative one. And we'll talk about why that is more in a little bit. But for now, we're just going to say the negative x means the negative line. And then we have two more that are both positive, which doesn't help us. We already know it's not this one. What happens if we do a plane y equals x? So that means if x is 1, y is 1. If x is 2, y is 2. So let's try it. If x is 1, y is 1. Yep, that works. If x is 2, y is 2. Yep. And I'm saying that because, let me grab this picture. I'll grab all three actually. Here's my new tab. Okay, so this coordinate that I have right here, ooh, where'd my pen go? I'm using another new tool today, trying to learn some new tools here. This coordinate right here is the coordinate 1, 1. X is 1, y is 1. And this is 2, 2. So that means when x is 2, y is 2. So is there ever going to be a point, 0, 0, negative 1, negative 1, negative 2, negative 2? Or is there ever going to be a point on this line where the x and the y don't match? Hopefully you said no. So that means that x and y do match. So that's going to be here. And then this one, I'm going to just tell you is 2x. And if you wanted to check it, you can say 1 times 2, because 2 is being multiplied by the value of x. So when the value of x is 1, 2 times 1 is 2. And we're going to talk more about why these are the way they are in just a little bit. But for now, we're just kind of getting familiar with some of the ways that rules work on graphs. So what is the rule that this blue line is following? We're going to do this together, and this video will have 2 parts to the lesson on it, so you will need to go through and watch the second video for lesson 1 so that we can finish all of our portions of our lesson together. So let's go ahead and take this picture here, and we're going to plug it into our notepad. I'm using a new notepad called bitpaper.io, and I really love it. It's a great free resource here, so if you ever need to do anything with collaborating with your peers online, it's a great one. Okay, so what's the function rule for this graph? Let's take a look at some of the coordinates. So this is what I like to do first. Just let's look at the coordinates and see if we can generate a rule. So when I'm looking for coordinates, I'm looking for ones that intersect perfectly along the axes. So it's not going to be like here where it's halfway and it's hard to tell. So this is the coordinate 1, 2, 3, 0. And then this one looks like it's another perfect coordinate here. That's 2, negative 1, 2, negative 1. This is 1, negative 2. And if you're wondering how I'm getting these numbers, I'm looking at the x line. So I'm saying this is 1, this is 2, this is 3. Then I'm looking to see how far down they go on the y line. So that's negative 1, that's negative 2, that's negative 3. So another coordinate that they touch right here is 3, 4, 1. So go over 4, up 1. And that should be enough coordinates. Let's see if this is good enough to help us get a rule. So looking at these rules, looking at these numbers, can you determine a rule that would change every one of these x's into a y? How do these numbers change from a 4 to a 1, or a 1 to a negative 2, or a 3 to a 0? Maybe you notice that they're all being subtracted by 3. 3 take away 3 is 0. 2 take away 3 is negative 1. So our rule is x take away 3 is going to give us y. Let's go ahead and finish this in the next video.